really lovely to have all of you here with us again. This is officially the first day of our winter school. So big warm welcome to all of you for this course. I think we have got 4 lessons, not I think, I know we've got 4 lessons. And in the first lesson, we are going to talk about functions. I don't know if you remember me speaking to you about what we would do. In the second lesson, I thought that we could speak about or look at some questions around the cubic function. But I want to have a little chat with you guys about that. I think just before we get started on what we're going to do today, I just want to go through the quiz first. And then I'm going to spend the rest of the time talking about Euclidean geometry. Okay, all right, so this was the quiz from last week. I just wanted to go through the answers with you. I don't know if there's any of these that you want me to work out in full. You can let me know if you do. The first one I think was really easy because there was nothing to be done there. You just simply had to go and apply the power rule to every term. So as far as your options were concerned, I gave you A, B, and C, and from what I recall, you were supposed to choose B as the right answer. I think, yes, there we go. So B was the correct answer. Does that make sense to everybody? Any questions about why it's B? All good. Okay, then as far as question 2 is concerned, that was also straightforward. What I wanted you to do here was remove the brackets using FOIL and then differentiate. So when you remove the brackets using FOIL, we would have ended up with x squared minus x minus 6, which means when we differentiated, we should have ended up with this, with f as our answer. Okay, so 2x minus 1. Okay, is everybody all right with that one? All good? All right, and then I slipped this one in. This was a bit of a nasty one. I know that every year when I teach calculus, when we do this question, people always end up getting it wrong. So that's why I thought I'd sneak it in there. Do you want me to work through this one, or can I work through it? Yes? Yes, please. Okay. All right, cool. Okay. Now, when we are differentiating, remember what we need to remove. So we always have to remove number 1, brackets, number 2, divide lines, and number 3 are radicals or roots. Okay, but when we say that we need to remove divide lines and radicals or roots, we need to remove them from variables, okay, not from constants or coefficients, okay? So divide lines and radicals need to be removed from variables. So what I'm trying to say is this. In this particular question, we have, let me just write it down, I'll write it a little bit bigger. We have root, and then inside the root is the 5 and the x, plus root 5 times x. So root 5 is the coefficient of the x term, plus root 5. Okay, so there are 3 terms in this particular expression. When we say that we need to remove radicals or root signs, we need to remove it from variables, not from constants. Okay, and why I'm going to show you right now. Okay, so equals dx, because we're not deriving just yet. So I'm going to leave this as root 5, and I'm going to write x as x to the power of 1 over 2. Does that make sense to everybody? So I've separated the coefficient and I've written x, instead of with a radical, I've written it with a rational denominator. Okay, as far as everything else is concerned, I can leave it exactly as it is. So root 5x plus root 5. Now, believe it or not, I'm actually ready to differentiate because I can see each term's coefficient. There's a variable, it's in the numerator, and I can see my exponent. Now I'm going to apply my power rule. So I'm going to drop my dx, I'm going to drop my square brackets, I'm going to apply my power rule to every single term. So a half times root 5 is root 5 over 2. Put down my x, and then I've got to take 1 away from the exponent. So a half minus 1 would leave me with a negative half. Okay, then I'm going to take my invisible 1, multiply it by root 5. So 1 times root 5 is root 5. Take 1 away from the exponent, so it becomes x to the power of 0, which is 1. Root 5 times 1 means that it's just root 5. And then the constant, the derivative of any constant would be 0. So root 5 is a constant, isn't it? So the derivative of root 5 would be 0. And that matrix would be your answer. Okay, so it looks really scary when we start off, but it's actually not a particularly bad problem. All right, so that meant that the final answer was what was the difference here? I can't see. You know what? How scary is this? I've got my glasses on, but I still can't see. What did I say the answer? Well, that's the answer. Okay, so it was G. Okay, there we go. Hi, Ryle. Okay, then as far as a question, yes, it is. Okay, cool. Thank you for helping me. Then as far as question number 4 is concerned, do you want me to do that one as well? How do you feel about question 4? Yes, no? Yes, okay, Johannes. No problem. Okay, so question number 4, let's do that down here. Okay, so, and then I will definitely do question 5 with you. That was supposed to be a difficult one. So we've got x squared minus 9 over 3x. Okay, so we've got find the derivative with respect to x. And then here at the top, we've got x squared minus 9. And then at the bottom, we've got 3 minus x. So hopefully you recall from the section or this course that we've just done on differential calculus, when we are differentiating and we have got a binomial denominator, we have to factorize. Okay, so what that means for us is that we need to factorize our numerator, and we're going to have to take a factor of -1 out of the denominator as well so that we can cancel down. So essentially our numerator, we're going to factorize by difference of squares. X squared minus 9 is difference of squares. So this will factorize into x plus 3 times x minus 3. And then at the bottom, I'm going to take out a factor of -1, and I'm going to write it as x minus 3 like so. Okay, now that I have done that, I can cancel. So something at the top with something at the bottom. Don't forget about this negative hanging around in the denominator. You are taking x plus 3 and you are dividing it by -1. So that is going to give us -x minus 3. Okay, so I'm dividing each term by -1. And then again, now I'm going to apply my power rule. So I'm dropping my dx, I'm dropping my square brackets, applying my power rule to those two terms, and thus I have to end up with -1 as my answer. And that's why up here, the correct answer was B. Okay. All right, so yeah, not as bad as question number 3, I guess, but there we go. And then the last one, question 5. Let's do that one together as well. Okay, so I'm just going to write it down here. Actually, we don't need this, that bracket there. Sorry. plus 2 over root x, and that was squared. Okay, so in this particular question here, Matrix, there's quite a lot going on, isn't there? Because we've got, it's okay, Void Shepherd, welcome. We've got all three things to remove. We've got to remove the radical, we've got to remove divide lines, and we've got to remove brackets in this case. So this really is a combination of all three skills in one, which is one of the reasons why I chose this particular question. If it's all right with you, I'm going to do more than one thing in a step. And if you don't understand what I'm doing, then please do ask, okay? But I'm obviously going to explain what I'm doing as I write everything. Okay, so I'm not differentiating, so I'm writing equals dx, and I'm keeping my square brackets. In my first term over here, what I'm going to do is I'm going to separate the coefficient from the variable. So I'm going to write it as 1 over 2 like so, and then I'm going to write my x and I'm going to write it to the power of a half. Does that make sense to everybody? So I've removed the divide line essentially, and I've also removed the radical from the first term. Everybody happy with that? Okay, then as far as my second term is concerned, my coefficient is 2. I'm going to remove the divide line. I'm going to take that root x into the numerator. And because I've taken it into the numerator, I also need to change the sign of the exponent. So that is going to become to the power of minus 1 over 2. Is everyone good with that? Yes. And then because okay, cool. If there's anything that I'm doing that you don't understand, please interrupt me, and I will happily explain it to you. And then, of course, because I'm squaring my bracket, I'm multiplying it by itself. So I'm just going to write down a half x to the half plus 2x to the minus 1 over 2. Okay. And now I can do the last step in terms of preparing my statement for differentiation, which is to remove those brackets. So again, I'm not differentiating yet. I'm going to keep my dx, I'm going to keep my square brackets, and now I'm doing FOIL. Okay, so first times first, a half times a half is a quarter. Write down my x. When I multiply like bases, I add my exponents. So a half plus a half is 1. So that's why there's an invisible 1 sitting on that x. Now I'm going to do the O. That was the F part of FOIL. So it was this bit. Now I'm going to do the O part. All right. So a half times 2 is 1. So it's going to be plus invisible 1. And then when I multiply like bases, I add my exponents. Okay, so as far as x is concerned, I'm going to have x to the power of a half plus a negative half. That's going to give me x to the power of what? X to the power of? Yes, indeed, x to the power of 0. So x to the power of 0 means that it's going to be 1. Is everybody happy with that? Okay, so when I multiply the first term in the first bracket with the second term in the second bracket, I'm going to get 1. Are we all good? And then we would get exactly the same thing when we do the O. So it's going to be plus another 1, whoopsie daisy. And then when we do the last step of FOIL over here, it's going to give us plus 4x. And when we multiply like bases, we subtract our exponents. So a minus half minus another half will give me minus 1. Okay, so that means collecting like terms together, we now have 1/4 x plus 2 plus 4x to the power of negative 1. Is everybody cool with that? I hope so. Please do ask if you're not sure. now that we have removed our radicals, our divide lines, our brackets, we've collected like terms, we've separated coefficients from variables, the variables are in the numerator, blah, 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 all the other things that we need to do before we can differentiate. We're now finally ready to apply our power rule to each term. So we indicate that we are doing this by dropping our dx and our square brackets and applying the power rule. So invisible 1 times 1/4 is 1/4. Of course, if I take 1 away from 1, I would get x to the power of 0. So that would be 1/4 times 1, which is 1/4. The middle term is a constant that becomes 0. And now, careful, careful, a negative times a positive. Okay, positive times a negative is going to leave me with a negative. All right, 4x to the power of, take 1 away, and that's where I get my -2 from. Okay, matrix. Cool, Thelma. Okay, so now that we've spent a little bit of time talking about the answers from the quiz, what I'm going to do is whip over and go and have a look at the questions that I've prepared for this evening. If we don't finish what I have planned, we can always carry on with it tomorrow. I really want this to be driven by you and your needs, but I'm also sort of using my common sense as well and sort of working on things that I know matrics notoriously struggle with. So I hope you don't mind, but what I've chosen is the first thing for us to do this evening is a question on normal functions. This is not something, that's right, you guys did do well in the quiz. Yeah, that's also true. Yeah, so yeah, you guys really do need to try these quizzes just to make sure that you are able to do these questions. It'll give you an idea of what it is that you need to focus on as well. Okay, so this particular question is an exam question. It comes out of a year-end paper, so typical sort of thing that you can expect. Nothing that's been asked in this particular question is, in my opinion, very, very difficult, but let's work through it and we can talk about it. All right, so in the diagram below, A and B are the x-intercepts of the graph of f of x, which is x squared minus 2x minus 3, a straight line G. Through A cuts F at C, which has the coordinates 4 and 5, and the y-axis at 0 and 1. M is a point on F and N is a point on G, such that MN is parallel to the y-axis, and MN cuts the x-axis at T. So all sort of fairly straightforward standard stuff. The first thing that they want us to do is show that the equation of G of x is negative x plus 1. So instead of me always telling you guys what to do, what would you do here? What do you think is the correct thing to do here, matrix? How could we start this question? Bearing in mind, there's 2 ways that we could do this. What do you think is the right thing to do here? What do they want from us? Sure, Aisha, go for it.
Hello.
Hello.
Hi, sorry. So we see that g of x is a straight line, and so we'd use the y equals to mx plus c formula, and then we see that we have a point C, with coordinates 4, 5. So we'd then substitute what's this, 4 and 5 into the y and the x. I'm just trying to see how we're going to get the gradient. Okay.
You are absolutely 100% correct. And you know what you can do from here? I've written down exactly what you said because it was perfect. They have told us over here, Aisha, that the line G cuts through the y-axis at that point. So essentially, they are telling us that C is equal to 1, aren't they? So if we can go ahead and just pop that 1 in over there, we can work out the gradient like this. Okay, so what you said there was absolutely perfect. All right, well done. Okay, so if I bring the m term over to the left and I bring the number term over to the right-hand side, we would get minus 4m equals minus 4, and therefore m would be equal to 1. So m is 1, c is 1, and therefore g of x is the line, equals x plus 1. All right. Okay, so good job. The other thing that we could do here, if you wanted to, this would be the quickest way of doing it. The other thing that you could do here, Matrix, is that you could calculate the gradient of the line using the y-intercept and this point over here. All right, so your alternative here was to go m gradient is 5 minus 1 over 4 minus 0, which will give us that gradient of 4 over 4, which is 1. And then again, we would have had to go and substitute in. Okay, so once we know that the gradient is 1 and c was equal to 1, we could have therefore said, okay, well, g of x is going to be the line x plus 1. Okay, so that was our alternative here. The next thing that we need to do is calculate the coordinates of A and B. Okay, so that's super easy. Why don't you guys go ahead and go and do that? You do the coordinates of A and B. And you can also determine the range. You should be able to do that as well. And then we can move on to 6.4. I'm going to give you 6 marks. So I'm going to give you 7 minutes. If you're done sooner, then just say so. Okay, and then we'll carry on. Oh, are we finished? Nice, good job. Well done, Marco. Well done, Kanyisile. Absolutely, that shouldn't take too long. Cool, Thelma. All right, so as far as 6.2 is concerned, what's super important here is you are calculating the coordinates of A and B, so you must make f of x equal to 0. Okay, do not forget, I mean, I'm sure your teachers at school have stressed this. Do not forget that when you factorize it, it still needs to be equal to 0. Okay, a lot of people leave that off. If they award you an accuracy mark on this line and you leave off the equal 0, then you're going to be penalized that accuracy mark. Okay, and then here you should have had x plus 1, and here you would have had x minus 3. So either x is equal to -1 or x was equal to 3. So therefore the coordinates at A would be -1 and 0. The coordinates at B would be 3 and 0. I trust everybody was able to do that. Okay, now the next question, they have asked us to determine the range of f. Now, normally, if they give us the coordinates at the turning point, determining the range would just be for 1 mark. But the fact that this is out of 3 means that we do not know what the y coordinate at the turning point is, and we have to calculate it first. So now, if we want to calculate the x coordinates at the turning point to get the y coordinates at the turning point, there are 3 ways that we can do it by the time we get to matric. Okay, so what are those 3 ways? Can you guys tell me? There are 3 things you could do with the information that you have at your disposal now. Did you know that there were 3 ways that you could do it? So way number 1, you could use midpoint formula. Okay, so in other words, x equals -1, whoopsie, plus 3 over 2. Okay, because your x coordinate at your turning point is going to be halfway between your x-intercepts. Okay, so that means that x would be equal to 1. Okay, the second way that you could do this is to use that formula from grade 11. Do you remember the formula x equals -b over 2a? Okay, so in this case, you would have ended up with that over 2 times 1, and you would have also got x is equal to 1. And the third way that you could have done this is you can use calculus, right? Because the gradient at the turning point is 0. Okay, so f prime x, in this case, it would be equal to, we're deriving now, so 2x minus 2. At the turning point over here, any tangent drawn to the turning point over there is going to have a gradient of 0. So 0 equals 2x minus 2. So again, 2x is equal to 2, and x would be equal to 1. Can you see there's 3 ways for you to do that? Okay, so you decide whatever is the easiest for you. And then calculating y, there's only 1 way to be able to do that. We have to then go and sub 1 back in. So f of 1 gives us 1 squared minus 2 times 1 minus 3. And then we end up with -4. All right, so to cut a long story short, the range in this particular question, we can either write it using interval notation or we can write it using set builder notation. So either, because the graph is smiley face, so either y is greater than or equal to -4, or if you're someone who likes the interval notation, y is an element of, -4 is its minimum, and it goes up to positive infinity round bracket. Okay, everybody happy with that? Nice. All right, let's carry on. Now, if mn is 6, well, what does that mean? What do they when they say to you mn is equal to 6? What is mn?
Ma'am, is it the length?
It is. It's the length between the parabola and the straight line. Okay, so quite right. So Cassandra, if MN is equal to 6, determine the length of OT if T lies on the negative x-axis. Show all your working. So Cassandra, where would you start with this question? What would be the first thing you would write? Okay, so I'm glad we're doing these questions because you guys are fairly quiet. I don't know if it's because you're tired or if it's because you don't know, but either way, I'm glad that we're doing these questions. So MN is a Y, isn't it? Okay, so MN is a difference in Y. So Y is equal to, now, M is a point on the parabola, N is a point on the straight line. So in order to get the vertical length of MN, we would have to say x squared minus 2x minus 3. I think I have copied that down correctly. Minus, okay, so the y on M minus the y on N, x plus 1. Does that make sense to everybody? So MN is the y on M minus the y on N. This gives us y is equal to x squared minus 3x minus 4. Is everybody happy with where that comes from? So I've just removed the brackets and simplified like terms. And then they told us, okay, over here, they told us that MN is 6. So that means that we need to go and sub 6 in where, matrix? In place of the
X.
Y,
okay.
ma'am.
In place of the Y, yes, absolutely. Okay, in place of the Y. All right, because remember, it's X that we are solving for because they wanted to know the length of OT. Okay, so they wanted to know a horizontal distance. So in other words, if we want to know what a horizontal distance is, we need the X coordinate at this point so that we can work out the length of OT, which is what the question asked us to do. Okay, so calculating the length of OT means we need to calculate what the X is at T. If they want us to calculate the X at T, it means we need to know what the corresponding Y is. All right, so 6 equals x squared minus 3x minus 4. This is now quadratic. This would become x squared minus 3x minus 10. Factorizing, we would end up with this. So therefore, x equals 5 or x equals -2. All right, now remember, it said to us here that OT lies on the negative x-axis. Okay, well, we can see that from the diagram. So OT lies on the negative x-axis. So that means that we are going to choose our negative answer. Okay, so therefore at T, X will be equal to -2, which means that OT must be 2 units long. Okay, we all good with that? Yeah. All right, Panyasila, does that make sense to you? Okay. Let's continue. Where were we? All right. Okay, so that's 6.4.1. Hence, so in other words, using what we've just done, write down the coordinates of N. So when a question says hence, you have to use what you just calculated, all right? If you don't, then they will penalize you. If it says hence or otherwise, then you can do things using another method. But if it says hence, you've got to use what you've just calculated to work out the answer. What can we say about M and T and N? They are all in the same?
All in the same line.
All in the same vertical line, absolutely. So if they're all in the same vertical line, that means they share the same
X-axis.
X, absolutely. They share the same X coordinate. Lovely, lovely, lovely. So in other words, at M and T and N, X has to be equal to -2. N is a point on G, on the straight line. So what that means is that we now have to take this answer over here and sub that. Okay, so here in 4.2.1, remember G of X equals X plus 1. We want to work out Y because we already know what the X is. So Y is equal to -2 plus 1. So that means that Y is equal to -1. So therefore, the coordinates at N have to be -2 and -1. Okay, matrix. 6.5 now. Determine, this is now where things start to get a little bit more interesting. All right, determine the equation of the tangent to F drawn parallel to G. Determine the equation of the tangent to F drawn parallel to G. Okay, so when they tell us that it's drawn parallel to G, what information does that give us about this tangent?
Ma'am, they have the same gradient.
They have the same gradient, absolutely. All right. So what is the gradient of the tangent? In this case, the gradient of the tangent is? This is information that we already know. Remember, we know that the gradient of the line G of X equals X plus 1. We know that the gradient of this line is? Exactly, Boucle. Okay, it's 1. Okay, the invisible 1 in front of the X. So we know that the gradient of this line, good matrix, all right, is 1. Remember last week we were talking about, let's just get it down. Remember I was showing you that little picture that I like to draw for my matrix. So gradient and X and Y. All right, bearing in mind there is more than one way that we can do this particular question, but this is what I would do in this case. All right, so if they've given us the gradient, all right, we know that the gradient is 1. The next thing that we need is the X coordinate at the point of tangency so that we can get the Y coordinate at the point of tangency so that we've got our Y and our M and our X that we can sub in, and then that means we can work out our C, and then we've got the equation of our tangent. All right, so if we have got the gradient, we have to calculate the X next. How are we going to use the gradient in this particular case? What are we going to do? How are we going to work out the X where the gradient is 1? How will we do that, matrix? Oops. The gradient at the point is the gradient at a point is the derivative, isn't it? Okay, so the gradient at a point is the derivative. So if the gradient at a point is exactly, Tisha, is the derivative, what that means for us is this. Okay, in 6.5, the gradient at a particular point, we know that the first derivative of this will be 2x minus 2. And we know that the gradient at this particular point is 1. So now we can solve for the corresponding x. Do you see what I'm doing here? I've subbed in what the gradient is, and now I'm going back and I'm working out what my x is. All right, so I'm going to add 2 to the side, add 2 to the side, and that means that 3 will be equal to 2x, which means that x will be equal to 3 over 2 at the point of tangency. Now to get the corresponding y coordinate at the point of tangency, so now I'm doing this bit over here, I've got the x, now I can get the y. I'm going to go and sub in 3 over 2 into the original. Okay, so in other words, I now want to calculate essentially f of 3 over 2. Right, so f of 3 over 2 leaves me with 3 over 2 squared minus 2 times 3 over 2 minus 3. And my answer to that will be, and I did this earlier, I got negative 15 over 4. Are you guys getting the same answer? Okay, so that means we've got the gradient, the m at t, we've got the x at t, we've got the y at t. All right, everybody happy with that? So the m at t in this case is 1. The gradient at the point of tangency is 1. The x coordinate at the point of tangency is 3 over 2. The y coordinate at the point of tangency is this nasty negative 15 over 4. All right, so now we are ready to go and find our equation. Let's just get rid of this other writing that's here quickly. Go. All right, that's all gone now. Cool beans. All right, so now subbing into y equals mx plus c, we are going to say negative 15 over 4 equals 1 times 3 over 2 plus c. Okay, so taking that 3 over 2 over to the other side, I get a c value of negative 21 over 4. Okay, so therefore the equation of the tangent, it is the line y equals 1x minus 21 over 4. Okay, matrix, everybody happy with that? Cool beans. All right. And now for which values of k, well, f of x equals x squared minus 2x minus 3 and h of x equals k plus x not intersect. Okay, so can you see here, this question is only out of 1 mark. All right, it is an interpretive question, but it's based actually on what we've already done. So in 6.5, we actually have got all the information that we need to be able to answer 6.6. So when they say not intersect, what they mean in this case is that the straight line, so in other words, your parabola is like this, and when we have worked out that it is a tangent, okay, so the corresponding y coordinate over here, all right, is minus 21 over 4 when it's a tangent. Okay, so this letter K over here represents the value of the y-intercept when the straight line no longer touches the parabola. So in other words, what we've done with the straight line matrix is that we have pulled it down. Okay, so if we pull it down like that, so in other words, if K is a value that is smaller, because obviously we go smaller when we go down on Y, if K is smaller than minus 21/4, then it means that that straight line will no longer touch the parabola. Okay, so that's our answer for 6.6. Okay, so 6.6, where K is smaller than negative 21/4, that's supposed to be a 1. Does that make sense to everybody?
Yes, ma'am.
Okay, thanks, Cassandra. Everybody else, you happy?
Yes, ma'am.
Good stuff. Nice. Thanks, Oratila. Thanks, Thelma. All right, let's barrel on. I see we've only got 15 minutes left. I know we took up a bit of time going through that quiz, but anyway, we needed to do that. This is another question from a paper that I went and dug out. And I really do want to do this question, the whole thing with you, because there are some sort of difficult, well, there's a particularly difficult question at the end that I would really like to be able to do with you guys. So if I don't finish this today, because there are only 10 minutes left, I would please like to come back to this tomorrow. Let's see what we can do now, though. So in question 4, they've given us 2 graphs. So in this case, they've given us f of x, which is a parabola. So by giving us f of x equals x squared plus bx minus 3, they're giving us some important information. First of all, they are specifically telling us that the coefficient of the x squared term is 1. All right, and they are also, by giving us the minus 3, they are also giving us the coordinates at which point. By telling us that it's f of x equals x squared plus bx minus 3, that minus 3 tells us that the coordinates at which point are what? Let's see what you're popping in the chat. Okay, so Boyd-Sheppel, if we have a look at f of x, it is the graph of x squared plus bx minus 3. This minus 3 over here, I'm asking you basically, Boyd-Sheppel, what does that mean? How is that value minus 3? It's related to the coordinates at which point on the graph, Boyd-Sheppel? Ah, there we go. Lovely, Aisha. Lovely, Tisha. Quite right. That's exactly it. Okay, so the coordinates at D are 0 and negative 3. Lovely. All right, and G of x equals A over x plus P. Now, again, they've given you information here, all right? They are implying that this particular hyperbola has been shifted horizontally, but it has not been shifted vertically. Okay, so by saying G of x equals A over x plus P, they are implying that the value of Q is 0, and that's why the graph has not been shifted vertically, because its horizontal asymptote is still the line y equals 0. Okay, so this is the sort of information that you need to be able to gather when you read this information. All right, then we're going to go and have a look at the rest of the stuff that they've told us. F has a turning point at C. All right, they've labeled that for us, and it passes through the x-axis at 1 and 0. That's also been labeled. D is the y-intercept of both F and G. The graphs of F and G also intersect each other at E. Okay, so that's down there, and J. Okay, so at E and at J. So these graphs actually intersect one another 3 times. Can you see that matrix? They intersect at E and D and J. All right, so there's 3 places where they cut one another. The vertical asymptote of G passes through the x-intercept of F. So the vertical asymptote of G passes through the x-intercept of F. So that also gives us some important information. What exactly are they trying to tell us? I mean, what do we interpret from that? So just like f of x equals x squared plus bx minus 3 means the coordinates at D are 0 and -3, what does the vertical asymptote of G passes through the x-intercept of F mean? Can anybody tell me? It's actually the answer to the first question, believe it or not. All right, so again, I'm glad by the fact that you guys are not answering this. I'm glad that we're doing this question. All right, so that bit of information, they are specifically giving you the value of P. Would you believe it? So the vertical asymptote of G passes through the x-intercept of F is their way of telling you what the value of P is. All right, because they are implying to you, all right, that the equation of the vertical asymptote, it is the line x equals 1. The graph has been shifted 1 unit to the right. So in other words, if we now go and substitute into our g of x, we would write this. Not that this is the answer to the question, but this is what we would have written. A over x minus 1. So they are in fact telling you what the value of P is. All right, so this bit of information over here. Okay. Write down the value of P. There you go. P equals -1. Do you see how important it is to be able to understand the information that you are being given, right? So everything that they tell you means something. All right. Everybody happy with that? Okay, let's carry on. Good stuff. Show that A equals 3 and B equals 2. All right, so what are we not allowed to do here, guys? In these, show that. No, Tisha. No, P is not equal to 1. Okay, and you know what? Lots of people would make that mistake. All right, so remember, when it comes to functions, when we shift something to the right, it has to change its sign, okay? Because remember, if I take the denominator, so in other words, if I take this and I equate it to 0 and I solve for x, the answer that I get has to be the equation of the vertical asymptote, which indeed it is. Okay, so P is equal to -1. Very, very common mistake. Okay. Right. What's really nice to see, yes, so Valerie, Aisha, and Kanisile, absolutely, you guys are all 100% correct. We are not allowed to use the 3 or the 2. All right, we've got to arrive at these answers on our own without subbing those values. And if we sub those values in, they will give us 0 for this question, which would be most unfortunate because this question is out of, okay, it's only out of 3. Okay, it's not too bad, but still, we don't want to lose any marks if we don't need to. All right, so showing that A is equal to 3 and B is equal to 2, can we sub in D, says Kanisile? Absolutely, we can. Okay, so that would be allowed, not a problem at all. Why don't you guys try that? Okay, so yes, you can use point D, that's not a problem. Point D is a point that lies on both of them. So yes, you can most certainly use the coordinates at D, which is another reason why we discussed why the coordinates at D were 0 and -3. Do you guys want to try that quickly? And then we can move on. Awesome stuff. Amazing. Well done, can you see? No, it wasn't meant to be a difficult question. It's supposed to be making us feel good. All right, so I quite agree. So here we would have said -3 equals a over, and then you must show the 0. Okay, matrix. -1, like so. Okay, so cross multiplying, that means that we would end up with a being equal to 3, and then subbing the same point into the other one, we would have ended up with -3 equals, oh no, hang on a second. Sorry, that's not going to work. That's not going to work. That's not going to work. Because then x would be equal to 0. Sorry, we're going to have to sub this point in over here. Okay, so when y is equal to 0, x is equal to 1. So that would be 1 squared plus b times 1 minus 3. And therefore, b would be equal to what would be -2. So that would be +2. Okay, so quick and easy. So yes, so in order to be able to work out the value of A, we would sub in the coordinates at D. We can't use the coordinates at D to work out the value of B, because then we would be subbing in 0 in place of the 1, our X coordinate, so that wouldn't work. So that's why we use the coordinates over here at the X intercept. All right, that means that we're sort of pretty much finished for today, because we still have to do the poll. What I wanted to ask you before I before we do the poll is, have any of you done, or are you all finished with calculus at school? Is there anybody? Okay, Bochep, I'm going to answer your question now. Have you all done the graph of the cubic function? Is there anybody who hasn't done the graph of the cubic function at school yet? Okay, Boychepo, you haven't done it. All right, that's fine. Okay, Bootley, you also haven't done it yet. Okay. You're still interpreting cubic graphs. Fine, Tisha. Are you guys happy with me doing these sorts of function questions? Can I finish this one tomorrow? Can I do another one that I thought was quite difficult? Are you happy with that? Thanks, Kanisile. Thanks, Aisha. You happy? All right. Happy. Okay. All right, so then what I will do is I will continue with this. Lovely. Thank you, everybody. Oh, that's awesome. Thanks, guys. Okay, so I will carry on with this tomorrow. I will finish this question off with you, and then I will do some other functions questions that I know are a little bit tricky and sometimes trouble us. Okay, so now, sorry, one last question. Bochepo, was it Bochepo? Hang on a second, let me go back here. Calling saying Bochepo, maybe it wasn't you. Yes, Bochepo. Ma'am, how did you get A to be 3? Okay, so Bochepo, I took a little bit of a shortcut here, but essentially what I've got is -3 from this line over here. I've got -3 equals, so A divided by -1 is -1A, right? And then I'm just dividing by -1 on both sides, so A is equal to 3. Or the other way of looking at it is you can cross multiply. Okay, so the -1 times the -3 gives us the +3. All right, so that's how we got A is 3. Are you happy with that, Bochepo? Cool beans. Can you see, Leigh? I'm going to type you an answer. Okay, so just so that everybody knows, our lessons continue as normal in the holidays. All right, we're using the holidays to, yeah, please do the poll. We're using the holidays to consolidate. All right, thank you, everyone.